طيب, let us quickly have an introduction about configuration the switching and the initial setting. When the switch is switched on, what will happen? So you will see multiple comments today and multiple concepts to be discussed in the context of the switching are a revision. We have covered them before, as you will see. So what we are going to talk about today is switching. Now, first step, we have a switch as a hardware device. We need to switch on the switch. So after the switch is powered on, it will go through the following 5 steps boot sequence. 5 steps. Why we need a boot sequence? At the end, any device containing or including an interface, iOS operating system, we need to boot and load the operating system. So once it's powered on, the first step on the boot sequence. First step, the switch will load a power on self-test post, let me say, program stored in the read-only memory. This program used to check the CPU system, dynamic RAM, and the portion of the flash device that makes up the flash file system. And we'll talk about the flash file system and the flash where it's used to store the image of the iOS. Once we're done with the post check completed successfully, the switch will load the bootloader software. It's very important, this one. Bootloader software is a small program stored in the read-only memory as well, and it will run immediately once we completed the previous step, power on self-test, successfully. Step number 3, bootloader program. Now, the bootloader programs low-level CPU initialization. So it means what? It will initialize the CPU registers. We know any CPU containing actually of a registers. So initialize the registers which control where the physical memory will be mapped. If you have studied T103, you know what I'm talking about here, the quantity of the memory and the speeds. All of these initialization of the CPU will be performed by bootloader program. Step 4, bootloader initialize also the flash file system on the system port. Permanent storage file system device. Usually we have the iOS image on the flash file system. Finally, and this is the last step, bootloader locates and loads a default iOS operating system software image into a memory and gives a full control or the control of the switch over the iOS, the operating system. So we have 5 steps. Maybe in the final exam they will ask you to reorder the steps and you will have a matching question regarding these slides. Now, once the switch is boot, as we said, the overall control will be given to the iOS over the switch. Now, what's the boot system command? Now, bootloader, as we have said, will find the switch Cisco iOS image on the switch by using the following process. How? The bootloader will find the image of the iOS. Usually, we are going to go through these steps. نعم. المايك يا جماعة، إذا ما في question المايك. Type. So the bootloader will find the Cisco iOS image on the switch by using the following process. First step or first process here, how we'll find the iOS image. The switch will try or attempts to automatically boots by using the information in the boot environment variable. If this variable is not set, which means there is no details about the iOS path, name, location, the switch simply, in case the boot environment is not set, will attempt to load and execute the first executable file it can find. How it will be located? It's used the depth search here. So iOS operating system then initializes the interfaces using the Cisco iOS command found in a startup config file. Startup config file is called here config.txt, which located in the flash file system as well. Now, so try to find or check the boot environment variable, locate or initialize the interfaces using the iOS command on the startup config file, config.txt. Now, what we have here is an example. We can set the boot environment variable. We can, let me explain it like, identify clearly where is my iOS image is located on the flash as a file system. And usually the extension will be .bin for the image of the iOS file system. So in this example, as you see here, boot environment variable is set by using a boot system commands, where we use this command at the global configuration mode. So note that iOS is located in different folder and different path, so it should be specified. So also we can use the command show boot to see what's the current iOS boot file is set to. So let us see the example. Boot system. Why we are using this command? To set the boot environment. The switch will load Cisco iOS image for this environment. So boot system here is the main command. Flash is the device or the storage device. Now, first part here is the path for the file system. Maybe we'll have a multiple directories, then we can reach the final image of the iOS. And last one is the iOS file name. So booting the switch or power on the switch, iOS image will be loaded from this full path. How we can set it? We can set boot environment variable by using boot system. So it's very important to read these steps, understand the order, and how we can load the iOS image. Now, what we have here, we have an image for a Cisco Catalyst switch 2960. Now, most of the switches comes with, let me say, a panel indicator, LED panels indicator. The location is different from a switch to another one. But in general, switches are different or many status LED indicator lights. As you see, all of these are called on any switch LED indicator lights. We can use it, or you can use the switch LED indicators to quickly monitor the switch performance and activities. We can get let me say, a general information about the switch, about some activities, some performance from this small panel. So let us talk about what we have, or each LED indicator here. The first LED indicator, system LED. So it shows whether the system is receiving a power and functioning probably or not. Now, different colors will be used for the LED indicator to indicate about the overall status of the device. Now, I'm talking about the overall switch, not a specific port, okay? The overall switch. So, for example, when we talk about the system LED, so it or provide me with an information whether the switch is receiving a power or not. So, in case the LED is off, what does that mean? It means that the system power is not on. If the LED is green, means the system operating without any problem, normal operating. If the LED is amber, let me say orange, so the system is receiving power, but it's not function correctly. So different color with different indicator. Second one, redundancy or redundant power supply LED. Means if the main power source is down, this one will be the second power source. So RBS shows the RBS status. If the LED here is off, means the RBS is off, or it's not connected properly. For example, if the LED is green now, means the redundant power supply is connected and ready to provide a backup power. In case it's a blinking green, means it's connected, but it's not available because it's providing a power to another device. If it's amber, it's in a standby mode. Blinking amber now means we have a fault, switch failed, or a problem with the providing power. Next indicator, board duplex. Either it's operating full duplex or half duplex. So when it's a green, indicate board duplex mode is selected. Board duplex can then be understood by the light associated with each board, green and off or amber, as you will see in the coming table. Board speed also, by the way, the duplex and the speed, as you will see later on, it's the basic first configuration of the switch. When it's a green, it's the board speed mode is selected. And the board speed can be understood also by the light associated to each port. For example, if the LED of the board speed is off, means the board operated at 10 megabits per second, because we are talking about the speed. If the LED is green, I'm talking about this one more time. Board operating at 100 megabit per second. If it's a blinking green, يعني بيضوي بطفي أخضر, okay. Board operating at 1000 megabit per second, or we can say 1 gigabit per second. Power over Ethernet, PoE, it's present if the switch support power over Ethernet the speed to the power over Ethernet, and so on. Now, I have explained many colors with many indicators. So how you will memorize them? How you will memorize them? How you will remember what's the green status for each indicator, what's the amber? All of them, okay, summarized in this table. So this table gave me an overall lead indicator case. For example, redundant power supply. If it's off, as you see here, no redundant power supply. If it's a green, it's ready. If it's a blinking green, it's available, but it's ready, or it's up, but it's not available. It's a provider. If it's under, it's on a standby or a fault. Sorry, not only standby, as I have said before. Now, blinking amber, internal power supply in the switch failed, and redundant power supply is providing a power. Internal problem and RBS providing power. Alternating green or amber is not applicable here. Same for the power over Ethernet. If it's off, it's not selected or it's not available. Let me say green selected. Only we have blinking amber. It's not selected or some port issue presented. For the duplex, for example, off half duplex, a green full duplex. Any other blinking color is not available, and so on. So this table summarizes all the cases of the LED indicator on any switch. واضح الهدف منها هذه؟ Clear؟ طيب. Now, what if there is a problem? We cannot boot, we cannot load the iOS image. So we need to have a recovering from the system crash. If you have forget the password, for example, how you will log in. So we need to handle these issues. In general, the bootloader provides access into the switch in the operating system, or sorry, if the operating system cannot be used because of the missing or damaged system files. So the bootloader has a command line that provides access to the file stored in the flash memory. Bootloader can be accessed through the console connection by using the following steps. In other way, I have an iOS problem on the switch. I need to format my switch. There is a damage, so I cannot access the switch through the iOS. So what I can do, I will use the bootloader environment. So we can access the switch by using command line interface provided by bootloader. So how we can do this? Following or by applying the following steps. So bootloader can be accessed, loader can be accessed through a console cable connection by using the following steps. Step 1, connect the PC by using a console cable to the switch, console port. Open your terminal emulator, configure the terminal emulation software to connect to the switch. Step 2, unplug the switch from power cord. شيل الكهرباء من اللي هو الباور كورد البلاج. شيل الكهرباء. Now wait for 15 seconds. Then reconnect the power cable to the switch. After or within 15 seconds. Then press and hold down the mode button while the system LED is still flashing green. So connect with the console, unplug the power, plug the power, press on system or the mode button. Continue pressing the mode button until the system LED is turned briefly amber and then solid green. Once it's solid green, release the button. Now the bootloader switch prompt will appear in the terminal emulator. You will see this on the terminal emulator on the PC. So now I can format, I can configure the switch, I can recover my password by using command line interface, let me say, provided through the bootloader environment. So once this prompt is appeared in the terminal emulation software of the PC, bootloader command line support different commands to format the flash file system, reinstall the operating system, my switch is a crash, recover any lost or forgotten password. For example, we can use dir commands, can be used to list all files within a specific directory. Like the dir, we use it in the CMD. So in case we cannot access the system or the switch through the iOS, we can use the bootloader in order to get an access, recover any crashing over a form, flash memory. We can change the boot system, for example, location, password recovery, and so on. Now, what if we want to manage our switch remotely? We can get an access. The switch would be managed locally or remotely. Locally, it can be managed by using the local console cable between a PC and the switch. Now we can also control the switch and managing the access of the switch from a different network. So what we should use here to access the switch remotely, we should configure the switch virtual interface. So to prepare a switch for a remote management access, the switch must be configured with an IP address and subnet mask. What else? Now I need to manage my switch remotely. I will configure my switch with IP address and subnet mask. What else? A gateway. We need a gateway as well. So to manage the switch from a remote network, the switch must be configured with a default gateway as well. This is very similar to the configuration or configuring the IP address information in the host device. How we are configure an IP address for the host? Same commands, very similar to this. Now, as you will see later or in this figure, switch virtual interface on switch 1 should be assigned an IP address. Every switch actually having a switch virtual interface. Now, what we mean by switch virtual interface? SVI is virtual interface, virtual. It's not a physical port on the switch. So console cable used to connect to the PC that the switch can be initially configured. So in order to configure the remote, let me say, access management, we need to connect to the switch through the console, configure the remote access, VLAN, the IP, SSH, and then we can access our switch from a different network or a remote network. So, by default now, we are talking about the configuration. The switch is configured to have its management controlled through VLAN 1. All switch by default configured to have access management control through VLAN 1. This is the default setting, the default configuration. Now, all ports of the switch also assigned to the VLAN 1 by default. So, if they ask you, what's the default VLAN configured in all the switch? VLAN 1. Assigned to all the ports, VLAN 1. Can we leave it like this? No. It's like the default setting of the access point. So for a security purposes, it's considered a best practice to use different or other VLAN than VLAN 1. We can create a VLAN, we can configure it, we can assign it to a port. Now, how to create it will be covered in advanced courses, but keep in your mind, we should and we can create different VLANs. So, for a security, it's considered the best practice to use a different VLAN. We'll not use the default VLAN, VLAN 1, to configure the management access remotely of the switch. So, in order to configure the management access from the VLAN interface configuration mode, so we need to access the interface VLAN 1, for example, then IP address subnet mask should be applied to that switch virtual interface. Now, in the example, we are using the VLAN 99. So the switch virtual interface for S1 here is VLAN 99, not virtual LAN 1. So even if it's configured, VLAN 99 will not appear as up status until the VLAN is created and there is a device connected to the switch associated with VLAN 99. Now we can on the switch create different VLANs, different ports will be associated with different group of VLANs, as you will see in advanced courses or part 2 of the course. Keep in your mind also the switch might need to be configured with IPv6. For example, before you can configure a switch with IPv6 address on Cisco Catalyst 2960 running the iOS version 15.0, you need to enter the following commands at the global configuration. In case we have this switch with this iOS version and we need to configure the switch with what, or the interface with what, IPv6. So what the command should be entered? Switch dynamic or database management, sorry, SDM, prefer dual IPv4- and IPv6 default. Once we enter this command, we will reload the switch. After the switch is reloaded correctly, we can configure the switch and use IPv6 addressing. So let us take an example. Now suppose VLAN 99 is created. Suppose it's created. It should be created before this. So how we can configure a switch virtual interface? At the global mode, we will enter the configure terminal. Now we will enter the interface configuration, interface VLAN 99. Now we are at the interface configuration mode of VLAN 99. Now what we will do, we will assign an IP address. IP address, IPv4 address is 172.17.99.11 followed by the subnet mask. IPv6 address provided with a prefix 64, a global unicast address. Here, the global unicast address. But in case you are dealing with an older operating system of this switch, make sure that this command is executed and the system is or the switch is reloaded before. Once we enter the IPv4 and IPv6, we need to enable the management interface. We need to make it up, active, no shutdown. End to exit or to return to the privileged exit mode. Finally, we need to save the configuration. So copy running config, startup config. Have we covered some examples about this before? Yes. Module 10, when we talk about the basic routing configuration. Mainly most of the interface configured by using IP address or IPv6 address, no shutdown, end to exit the mode. Depends on the interface or the configuration. عندكم أي سؤال الآن؟ طيب, once the interface is configured, we need to configure the gateway. Otherwise, we cannot access the device, or sorry, let us ignore the access. A switch cannot respond back to a remote device on different network without a gateway. Without a gateway, in general, any device cannot communicate with any other network. So the switch should be configured with default gateway as well. If it will be managed remotely from a network that are not directly connected to this network. So how gateway can be configured? Configure terminal, enter the global configuration mode. Now at this one, IP default gateway, what's the gateway address? End and copy running config to startup config. So for sure the gateway will be the gateway of the local router here. R1. This is the default gateway of the switch. The interface of the local network on the router side. Also, we need to save the running configuration to the startup configuration. So copy running config, startup config. Now, modify the configuration. Initially, we can use show IP interface brief or show IPv6 interface brief commands. Useful for determining the status of both physical and virtual interfaces. The output will confirm that, as we see here, according to this example, the output will confirm that interface VLAN 99 has been configured with IPv4 and IPv6. So, in this example, we have used the command show IP interface brief. As you see, we have the interface ID or name, IP address, configured manual, status is down, protocol is down, when it will be up. After we have a port or a device connected to the switchboard and associated with VLAN 99 virtual network. So show IPv6 interface brief, VLAN 99, a global unicast IPv6 local link IPv6 address as well. So IPv6 here and IP address applied to the switch virtual interface is only for a remote management access to the switch. This does not allow the switch to route layer 3 packets. It's not for a local communication between the switch and other network devices, only for the remote access and the remote management. What we are talking about, telnet SSH, nothing more than that. Now, we need to talk about configuring the switch ports. Now, the first basic configuration of the switch port is to configure the duplex and the speed. Before that, let us take a quick revision. Communication of the duplex can come in two modes, full and half duplex. For the full duplex communication, it will increase the bandwidth efficiency, but why? Both devices communicate using full duplex method can send and receive at the same time. So both ends on the full duplex communication will transmit and receive data at the same time. What we call this bidirectional communication. And it requires micro-segmentation. So micro-segmentation LAN is created when a switch port has only one device connected to. We have a very small collision domain here. Another way. So if they are operating or AND is operating in full duplex mode, there is no collision domain, and we'll explain what's the collision domain in module 2 today. There is no collision domain associated with the switch port operating in full duplex mode. Simply, one more time, main benefits of micro-segmentation, it will allow the ends of the communication to obtain an access to the full bandwidth instead of have to share it with other nodes in the network. So full bandwidth access, so the result, collision will be reduced greatly, especially in the full duplex environment. We do not have a collision actually if the communication is operated on the full duplex mode. Now, unlike the full duplex, half duplex is unidirectional, not bidirectional, means two-way. Full duplex, half duplex, unidirectional, one way. So half duplex create a performance issue, and data can flow only in one direction at a time. And usually it's the main source of what, or it might result in collisions. What's the collision? Two devices transmit data frame at the same time. Done. So gigabit Ethernets and 10 gigabit network interface card required, it should operate on full duplex. Requires a full duplex connection to operate. In full duplex mode, the collision detection circuits on the NIC is disabled. And be careful, it might be a tricky multiple choice question. Do we need to enable the collision detection if it's full duplex gigabit Ethernet? The question is no. The answer, sorry, is no. So full duplex offers 10 or 100% efficiency in both directions. So 100% efficiency at the sender side or the transmitting, 100% for the receiver. So we are doubling here, or the results in a doubling of the potential use of the stated bandwidth. So full duplex, we can send and receive, no collision. Half duplex, one direction or unidirectional, it will result a collision. Gigabit Ethernet, collision detection is disabled if it's operate at gigabit speed. Now, as I have said, first simple and basic switch configuration is to configure what? The duplex and the speed. So duplex and speed of a switchboard can be configured manually by using the commands duplex and the command speed. So duplex full, speed 100, for example. Duplex auto, speed auto. MDIX should be auto as well in this case. So the default setting now for both duplex and the speed as a default setting. When we talk about, for example, Cisco Catalyst 2960 switch and 3560 switch is auto. This is the default port setting for the duplex and the speed. Now, in case 100,000 megabits operate ports, talking about 10 megabits per second, 100 megabits per second, or 1000 or 1 gigabit per second, port operate in either full or half duplex when they are set to 110. So in case the speed 10 or 100, port can operate on full duplex or half duplex. In case it's 1000, it will operate only in full duplex mode. So collision detection here is disabled. This is what I was talking about in the last slide. So 1000, we have an option, full duplex or half duplex. 1000 megabit per second, full duplex mandatory. There is no option for the half duplex here. Now, auto negotiation is useful when the speed and the duplex setting on the device connecting to the port are unknown or may change. So we can set the duplex auto and the speed auto in case the device connecting to the port are unknown or it may change. We don't know what's the type of the device connected to the switch at that port. So auto here negotiation, it's the best practice. But when we connecting to a known device, such as a servers, dedicated workstations, network devices, the best practice here is what to configure and set the speed and the duplex manually. Also, when troubleshooting the switch issues, it's important that the duplex and the speed setting are checked. Why? Because we have a mismatched duplex issue. So mismatch setting means one of the ends operate, for example, in full duplex and the other end operates on half duplex. So what we have? Mismatched duplex, a problem here or issue. So mismatch setting for duplex mode and the speed of the switchboard can cause connectivity issue. Auto negotiation failure also rarely create mismatch setting as well. In case it's a fiber optic port, such as 1000 base ASAX port, it will operate only and always using full duplex. Now the question, how we can configure a switchboard, how we can use the speed and the duplex. In this example, we want to configure the switch 1 fast Ethernet 01. It should be a duplex mode full and the speed 100 megabit per second. So how it can be configured? We need to enter the global configuration mode. Configure terminal or config terminal. Now enter the interface. Interface fast Ethernet 01. So now we are at the interface mode. Now duplex full. So we have set the duplex to a full. Now speed 100 megabit per second. Exit the interface. Return to the privileged exit mode after we set the duplex and the speed. Finally, copy running config to startup config. Is there anything is not clear here? طيب, what's the auto or the automatic medium dependent interface crossover? When it's enabled, the interface will automatically detect the required cable type. We have a straight through cables and a crossover. So when auto MDIX is enabled, it will detect automatically the connection type. For example, in case it's off, we need to be careful. What's the type of the medium to be used? So when connecting to a switch without auto MDIX, straight through cables, for example, must be used when connecting to a devices like a server, workstation, router. In case we are or there is a connection to a switch or a repeater, a crossover cable should be used here. So in order to avoid any possibilities of using the incorrect cable to connect the devices, best practice is to use the auto MDIX, automatic medium dependent interface crossover. But in case it's enabled, any type of cable can be used between the devices or to connect to the other devices, and the interface in this case will automatically adjust to communicate successfully. So regardless of the cable, crossover or straight through, any of them can be used in case auto MDIX is enabled. But how it can be enabled? Simply MDIX auto. On newer Cisco switches, MDIX auto interface configuration mode command enables the feature. When using auto MDIX on the interface, the speed and the duplex must be set to auto as well. So let us add here or configure F01 as an auto MDIX with a speed and duplex. So configure terminal, interface fast Ethernet 01, duplex, auto, speed, auto, MDIX, auto, end, copy running config, startup config. What's the benefits? Any medium or any cable can be used between any devices, and the auto MDIX will adjust the communication according to the device's types. Now, keep in your mind, Auto MDIX feature is enabled by default in a switch or Cisco Catalyst 2960, 3560, but it's not available in older Cisco switches like 2950 or 3550 switches. How we can check now to examine the Auto MDIX setting? For a specific interface, we use show controllers Ethernet controller command followed by the keyword phi. Let me say. So in order also to filter the output, we'll add a pipe, include Auto MDIX filter. So when we run this command, we can examine if Auto MDIX is on the interface is available or it's set or not. Now, how we can verify the switch? How we can troubleshoot that switch in other case? In case we would like to troubleshoot the switch. This table, as you see here, summarizes some of the more useful switch verification commands. The most important switch verification commands summarized in this table. So, for example, show interfaces followed by the interface ID arguments, display the interface status and the configuration. Is it up? The protocol is up. Configuration details. Show startup config. Display the current startup configuration. Show running config, the current running configuration. Show flash, information about the flash file system. Show version. Display a system, hardware and software. Status. History, we can see the last or the previously entered comments. The default is the previously 10 entered comments. Show IB interface with an interface ID. Display IB information about the interface. So IB for IPv4, IPv6 for IPv6 interfaces. Finally, show MAC address table or show MAC address table, but only the difference here, the hyphen here. Display the MAC address table. So let us take an example about an output of each command and what's the benefit. Show running config commands. Show running config can be used to verify that the switch has been correctly configured. So what we have here, a sample or from the sample abbreviated output on switch 1, some of the important information is showing. So we run at switch 1 global mode show running config. So from the output, we can see that fast Ethernet 018 interface configured with a management access VLAN 99. VLAN 99 configured with the IP address 172.17.99.11. Subnet mask is provided. Gateway or default gateway IPv6 address as well for the VLAN, and the IP default gateway 172.17.99.1. So basic, or we can verify that the switch has been configured correctly or display a configuration details by using show running config commands. Show interfaces, which is the most important one in this class. Show interfaces commands is another command commonly used, which will display the status and statistic information on the network interface switches. So show interfaces commands is a frequently used when configuring and monitoring the network devices. For example, we are going to issue show interface fast Ethernet 018. So this is a sample of the provided output. Now, the output or the first line of the output here indicates that fast Ethernet 018 is up, line protocol is up, which means Ethernet running or operational correctly without any problem. Now further down on the output we can see it's operate on the full duplex mode where last line speed set to 100 megabit per second, media type 10 to 100 base XTX. So if it's 10 or 100, it can be either full or half. In our case here, it's a full duplex. So a duplex mode details provided, speed provided, hardware status can be shown and provided from show interfaces commands. Now, let us talk in more details about the output. The output from show interfaces command is useful to detecting or for detecting the common media issue. Now, one of the most important part of this output is the display of the link and data link protocol. Right. What I'm talking about here, I'm talking about the first line. So, according to the example below, the first line parameter fast Ethernet 018 is up. What does that mean? It's referred to the hardware layer. Now we're talking about network access layer issues. So it refers to the hardware layer indicating whether it's receiving a carrier detected signal or not. If it's up, hardware is up, receiving a signal, there is no problem. If it's a down, we have an issue here. Now, second parameter, line protocol is up, refers to the data link layer and indicates whether the data link protocol keeps alive, are being received or not. Now, based on the output of the first two parameters, based on the output of the first line including these two parameters, show interfaces output, possible problem can be fixed as the following. So we can know what's the problem actually from the output of show interfaces command. For example, if the interface hardware is up and the protocol line is down, we have a problem. So there could be in this case encapsulation type mismatch. Interface on the other end could an error disabled, could be error disabled, or there could be a hardware problem. If the protocol line and the interface both down the status, maybe the cable is not attached. Some interface problem exists. For example, a back-to-back connection, one-to-one connection. On the other end, maybe administratively down, shut down manually by the admin. So the status will be down in this case. So we can investigate the cause of the problem according to the output here. For example, if the interface is administratively down, It means it has been manually disabled, which means shut down, not no shutdown command was used or has been issued in the active configuration. So we turn off manually or shut down off manually the port. So show interfaces provide a good benefit information for a troubleshooting as well. Now we will continue as well. So we have explained the first output line. Be careful. What's the type of the question? They will give you the output and ask you questions about the output according to these three scenarios. Or a technician has issued show interfaces, comments as shown in the following screen. What's the problem according to the output? It might be a final exam question on CCNA2 or in the module or chapter exam of this module. But you will not do any of the modules exams or an exams from Net Academy for this one. Now, network access layer. Show interfaces command output display counters and statistics for fast Ethernet interface as shown here. Now, where is the statistics? Input and output errors. It's very important here as well. This input errors, we have 3 input errors, we have 8 output errors. So we need to talk about the output errors where we have already discussed the hardware and the line protocol status. Now, in general, some media errors are not severe enough to cause the circuits to fail, but do cause network performance issues. So what we have in this table explains some of the common errors which can be detected using show interfaces commands. So simply, I'm talking about 2 parts, input errors and output errors. Input errors in case of the input errors, we are talking about a statistical information provide me with a total number of errors. It will include runt, giant, no buffer, cyclical redundancy check, CRC, frame, overrun, and ignored count. We'll talk about it and discuss it. الكويز متى الكويز هو؟ الكويز يوم السبت. طيب ايش الرنت يا جماعة والجاينت؟
Again, دكتور؟
الرنت والجاينتس هذا بمادة الكويز. هذا جزئية الكويز تاع يوم السبت. ما عندكم فكرة يا جماعة، ذاكروا يا جماعة صدقا، هذا كله ريفيجن. لو انتم مركزين معي بالجزئية اللي قبل تكلمنا عن شو انترفيسز قبل هيك، لأن الرنت لما يكون الفريم سايز less than the minimum frame size أقل من 64 بايت it will be discarded. الجاينت more than the maximum allowed size 1518 bytes. CRC frame check sequence calculation problem. So CRC error are generated when the calculated check sum is not the same as check sum received. I have received the frame, we have FC as field. I have recalculated the value. Values are not matched. There is an error. Now, so usually input errors, talking about runt, giant, CRC. Output errors, collision and late collision. Collision, the number of messages transmitted because of the Ethernet collision. Collision, 2 end devices place a data at the same time. Now, later collision, a collision that occurs after after the transmission or after the 512 bits of the frame has been transmitted. So let us explain input errors, output errors in full details. Now, input errors is what? Is the total number, the sum of all errors in the datagrams that were received on the interface being examined. It will include, as we have said, run giant CRC, no buffer frame, and other errors. The reported input reports from the show interface comments include the following. What's I'm talking about? I'm talking about here. As you see, we have 3 input errors, all of them a CRC, which means what? 3 frames received incorrectly. Now, 8 output errors, collision problem and late collision as well. So what's the runtime frame? Ethernet frame, which less than, shorter than 64 bytes, which is the minimum allowed length of the frame, what we call it runt. Any runtime frame, what the Ethernet will do? What we will do to any runtime frame less than 64 byte at the Ethernet? It will be simply discard, ignored. So malfunctioning network interface cards are the usual cause of the excessive runtime frames, but also the cause or also be caused by the collision. Now, giant, the opposite of the runt. The frame is less than the minimum size. The giant, the frame larger than the maximum allowed size. The frame is larger than 1516 bytes. It will be discarded as well. CRC error. On the Ethernet and serial interfaces, cyclical redundancy. Cycles, error, cyclical redundancy check errors usually indicates a media or a cable error. The main cause includes electrical interference, loss or damage of the connection, incorrect cabling, so the frame is received or sent incorrectly. So if you see many CRC errors, there is too much noise on the link. In case we have a large CRC errors, means we have a large noise or too much noise on the link. Maybe electromagnetic interference is the source. So the link should be inspected. You should also search and eliminate the noise sources. Output errors, the sum of the all errors prevented the final transmission of the datagram out of the interface that being examined. Now, usually output errors including collision and late collision. What's the difference between them? Collision in a half duplex. Operations are normal. However, you should never see a collision on the interface configured for a full duplex communication. You will not see actually a collision if the interface configured with a full duplex. Now, what about the late collision? Late collision refers to the collision that happened or occurs after 512 bits of the frame already transmitted. Main source will be the cable length. For example, very excessive cable lengths are the most cause of the late collision. Another common cause, the duplex misconfiguration. One of the end is full, another end is half duplex, late collision source. The length or the cable length is too long, it might be or it might cause late collision errors or output errors. Now, finally, how we can troubleshoot the network access layer. To troubleshoot a scenarios involving no connection or bad connection between the switch and another device, following is the general process can be followed to troubleshoot the network or the switch, network access layer or the switch. So how we can troubleshoot our switch in case we have no connection or bad connection issues. Now we'll perform show interfaces command. So we'll have a details. Now we'll check, is the interface is up? First line face parameter is up. If it's yes, so it's receiving a signal. Now it's a signal, it's a connection issue. Are there any indicators for electromagnetic interference or noise? If yes, we need to investigate the noise source. We need to reduce or eliminate the noise source. After that, we need to verify also the duplex setting. Is it the same in both sides or not? So we are talking about here, this scenario, collision and late collision. Now, if the interface is not up, it might be a cable problem. Check the cable, check the connector if there is any damage. Check the speed that it's probably set in both ends. Speed is 100, for example. Once you have go through one of these two directions, we will move back now to this step. In this process, we need to ask a question. Is the problem solved? If yes, done, everything is fine. If no, it should be documented. So a documentation work to be done, and then just escalate the issue to the higher technician level. So this is an overall troubleshooting scenario can be used to manage or troubleshoot our switch. Now, how we can access our switch remotely? We have two options. We can use Telnet and we can use the SSH. Telnet usually uses port 23. It's older protocol and it's unsecure plain text transmission of the login and data transmission. What does that mean? Simply, if we are using a Telnet, whatever will be exchanged between the source and the destination will be sent in the plain text format. The authentication username and password will be sent in the plain text format. So as you see here, for example, we are using a Wireshark to monitor the connection. So the threat actor here sniffing the packets. From the packets, we can see what's the username and the password used to connect router 1 remotely through the Telnet. So the username is admin, the password is CCNA. So it's totally insecure. So second remote access is the SSH, secure shell. SSH is secure protocol, use a TCP port 22. It's to provide a secure encryption connection to a remote device, which means access authentication data, transmitted data will be exchanged between the communication devices in the ciphertext format, encrypted format of data. So same scenario, Wireshark here capture a SSH session. As you see, the threat actor cannot discover any data about username, password, data transmitted, because it's presented as a ciphertext, while when we talk about the Telnet, it's a plain text format. So, how we can check if our switch supports or can use SSH for remote access or not. To enable SSH now in Cisco Catalyst 2960, the switch must use a version of the iOS software including a cryptographic encryption features and capabilities. So how we can check, how we can know if our switch support SSH, which means support a cryptography اللي هو علم التشفير or not. We can use show version commands on the switch to see. Now, usually the iOS file name that includes a combination of K9 support a cryptography. So how we can know if our switch support SSH or not? At the global level, we run a show configure. Now we need to check the iOS. Where is the iOS? Okay, this one. Cisco iOS software, Cisco 2960. As you see with the file name, what we have K9. K9. K9 means what? SSH connection cryptography capabilities are enabled on this OS for this switch. Once we see K9 with a iOS file name, as you see here. Now, how to configure SSH, and we already, by the way, explained it before with a comments. I think in module, I'm not sure in which module, but it's already covered before. However, before configuring the SSH, the switch must be configured with a unique username or host name, and the correct network connectivity setting. So let us assume host name, IP configuration, all configured correctly without any problem. Now, step 1, verify SSH support. So, in this step, we will use show IP SSH command to verify that the switch supports SSH or not. Now we are not checking the operating system. We need to know, is the switch support the SSH or not? How? We write show IP SSH. If the switch is not running and iOS supports the cryptography features, the output will be unrecognized command. So simply show IP SSH. If there is an output, SSH is supported. Unrecognized command, iOS here version is not supporting the SSH. Step 2, configure an IP domain name. So configure the IP domain name of the network using IP domain name followed by the domain name. So IP domain name cisco.com, for example. At the global configuration mode for sure. Step 3, now we need to generate a keys. Why we need these keys? To encrypt the transmitted data and decrypt it between the parties of the SSH session. So generate RSA key pairs, one key for the sender and one key for the receiver. How it will be generated? By using a crypto key generate RSA at the global configuration mode. Also, we need to set the key size. So the minimum allowed key size, if you remember the previous modules talking about the same issue, 1024 bits. This is the recommended minimum key size. Now to delete a generated pairs of encryption keys, we can use a crypto key 0 RSA at the global configuration After the RSA key pairs is deleted, SSH server will automatically disable. Once the key pairs are generated, SSH server will be automatically enabled. So we configure a domain, we generate an encryption key. Now configure a user authentication, which means what's the username and password. So SSH server here can authenticate the user locally, or we can use authentication server. To use a local authentication, we need to create a username and password pairs. How? By using the command. Username, for example, admin, secret, Cisco is the password and the global configuration mode. One more time, username, admin, secret, Cisco, and the global configuration name. Finally, configure the virtual teletype. The access or the acceptable input line here. So enable the SSH protocol on the VTY virtual teletype line by using transport input SSH, transport input telnet, transport input both of them, but we need a secure connection. So transport input SSH. In the line configuration mode as well. Now use the line VTY as the global configuration mode, and then we need to enter login local at the line mode as well to require a user authentication. So transport input SSH, login local to activate or to configure the user authentication, which means a user authentication is required locally for SSH connection from the local username database. Finally, enable SSH version 2. By default, SSH supports both version 1 and 2. When support both of them, this is shown in the show IB SSH output as supporting version 2. Enable version 2 by using IB SSH version 2 as the global configuration. So IB domain name followed by the name, crypto key generator RSA 1024, username admin, secret Cisco, transport input SSH, login local, IB SSH version 2, copy running config, startup config, and the configuration is done. Now, how we can verify that SSH operate correctly without any problem? We can use any SSH emulator. For example, on a PC, an SSH client such as Betty emulator can be used to connect to SSH server, which is the switch in our scenario. So we will open the emulator, we will go to the configuration, we will put the IP address of the switch. Let us say, for example, we are talking about switch 1 in the previous diagram, okay? So we'll put an IP address. SSH is enabled, the port number. Now what's the IP address of the server? 172.17.99.11 on a switch 1. PC IP address is 172.17.99.21. So all of these details are entered by using the GUI when we open the SSH client software. Now, using the terminal emulator, initiate as such connection to the switch virtual interface VLAN IPv4 address on switch 1 from PC1. Once the connection is established, the user will be asked prompt to enter the username. So log in as admin. If the username is correctly located in the local database, now the user will enter what? After the authentication, the user will need to enter the password. So what's the password here in our scenario? CCNA. So after the correct password is entered, the user now is connected to S1, switch 1 via SSH connection command line interface on Cisco 2090, 2960 Catalyst switch. So what we have here, we have configured the SSH connection. We have checked that we can connect to the SSH switch. Finally, to display the version and the configuration data for the SSH on the device that you configured as an SSH server, use the command show IP SSH. So output give me that SSH is enabled, its version 2, authentication timeout 120 seconds, authentication restricted to or retries only 3 times the incorrect password can be entered. Now we'll talk about the basic configuration of the router. Basic routers and Cisco switches have mainly similarities. They support a similar model, operating system, similar command structures, and many of the same commands. So as you see here in the example, we can configure a router by using the host name. We can secure the configuration modules, enable secret class, line console 0, the user mode, password Cisco, login, enable the password authentication. We can secure the virtual teletype from 0 to 4, as we know that, okay, we have 5 here, virtual interfaces, password is Cisco, login exit, service password encryption in order to display the passwords on a ciphertext format. Also, we can configure a message or a banner, message of the day. We can use banner MOTD with any warning or notification message, unauthorized access only, as we can see in this example. We can save the changes by issuing the command save running config startup config. Simple router configuration commands covered in module 10, by the way. Now, please focus here. One of the differences, features between switches and routers is the type of the interfaces supported by each one. For example, layer 2 switches support a LAN. Therefore, they have a multiple Ethernet or gigabit Ethernet ports only. Now, dual stack topology in this figure is used to demonstrate the configuration of router IPv4 and IPv6. As you see here, we have 1, 2, 3 interfaces in the router. We have a dual stack, which means IPv4 and IPv6. Now, please remember this scenario. Router 1 connected to switch 1 through gigabit 000, connected to S2 through gigabit 001 connected to R2 through a serial connection 010. Type routers means that the routers supports LAN WAN interfaces and can interconnected with different types of network. So they support different type of interfaces. For example, in the previous figure, G2ISR Generation 2 Cisco Integrated Services routers have one or two integrated gigabit Ethernet interfaces, high-speed WAN interface card, a slots to accommodate other types of network interfaces, including serial DSL cable interfaces. Now, to be available to activate an interface, for the interface to be alive, the interface must be same configuration, same issues when we talk about the Ethernet port. Any router interface, regardless of its type, LAN, WAN, DSL, high speed, integrated card, it should configure with at least one IP address. So we use IP address, the value with the subnet mask, and IPv6 address with the address and the prefix in case of IPv6 configuration. Now, it should be activated. By default, LAN and WAN interfaces are not activated on the router. How it will be activated? No shutdown. So to enable an interface, to activate an interface, we should use no shutdown command after the IP address of that interface is issued. So it's similar to powering on an interface. Now we can add some description about each interface. We can write up to, or we can use up to 240 characters as a description. Each recommended to be have it, and it's helpful for the troubleshooting. I can know this interface connected to which network, for example, from the description over that interface. So a quick example here will configure 1, 2, 3 interfaces on router 1, gigabit 00, 01, and the serial interface. So we need to access each interface, assign an IP, activate it, log out, and so on. So interface gigabit Ethernet 000, now IP address 192.162.10.0, subnet mask is provided, IPv6 address, description is used here, link to LAN 1. No shutdown, exit. Now we'll repeat the same configuration commands to interface 001. We'll repeat the same interface configuration to serial 000 as well. So all interfaces on router 1, according to this configuration, have been configured correctly. What else we can do? We can configure a loopback interfaces, virtual interfaces. So another common configuration on Cisco routers is to enable a loopback interface. Loopback interface simply, it's a logical interface that is internal to the router. It's not assigned to a physical port and can never be connected to any other port. It's a virtual port. It's considered a software interface that automatically placed in an up state as long as the router is functioning. This is the main advantages. It's always up as a status. So the loopback interface is useful in testing and managing the Cisco iOS device because it ensures that at least one interface will be always available. So we can use, or it can be used for testing purposes, testing internal routing process, emulating the network behind the routers. Also, we can use it on the lab to simulate multiple networks with different types connecting to different loopback interfaces, as you see in the next point. So loopback interface also can be used in a lab environments to create additional interfaces. We can create multiple loopback interfaces. Every single loopback interface connects to different networks. Now, how it can be configured? At the global interface loopback, we should assign a number, interface loopback 1, IP address, and subnet mask. But be careful, each loopback interface must be unique and unused by any other interface. Usually, loopback interface used to simulate the link to the internet, so it should be a unique IP. How many loopback interface can be configured on the router? It's up to you. It's up to you. It's a virtual interface. Virtual. Now, verify the directly connected network. Verify the interface configuration another way. So, there are several show commands that can be used to verify the operation and the configuration on interface. I'm talking about the routers here. Following commands are especially used to quickly identify the status of the interface. We can use show IP interface brief or show IPv6 interface brief. These commands used to display a summary for all interfaces, including 4 and 6 addresses of the interface and the current operational status. Show running config interface, interface ID. Display commands applied to the specified interface. Now show IP route and show IPv6 route. Display the contents of the IPv4 or 6 routing table stored in the random access memory. In Cisco iOS 15, active interfaces should appear in the routing table with 2 related entries identified by C, directly connected, link, local link connected. Any previous version IP routing table will appear with a single entry code C only. Right. Have we discovered or have we covered all of these previously? Yes. Now you will remember in unit 9, not 10, the previous one. Now, what's the output? What's the benefit of show IP interface brief? It can be used at the switch and the router. Same concept, same issue. This command will use to display a quickly information about the status of the all interfaces. So I have the interface ID, IP address, status, protocol. As you see, for example, serial 0111 is administratively down. Shut down manually. Show IPv6 interface brief. Ethernet, status is up. Unicast address, local link address. 2 IPv6 addresses, not 1. Gigabit 1, status is up, protocol is up, 2 IPv6 address, 2 IPv6 addresses, and so on. Now, the output of the IPv6 interface brief command usually will display 2 addresses per interface. The first address is the global unicast address, the unique internet address, the address that we use it to connect to any device on a different network. The other address, which always begin with FE80, it's what? Link local unicast address for the interface. So we have link local address, global unicast address, link local, global unicast for every interface. The link local address is automatically added on the interface whenever the global unicast address is assigned. IPv6 network interface is required to have link local address to communicate with all the other devices locally, but not necessarily to have a global unicast address. Now, in the below example here, we have used show IPv6 interface for gigabit Ethernet 000 command. So it displays the interface status is up, line protocol is up. What else now? We have the global unicast address. We have the local link address. And as you see here now, along with the local link address and the global unicast address, the output includes 3 different multicast addresses. How I know it's a multicast? FF02, multicast joint group assigned to the interface. Usually, multicast addresses or always begins with FF02. So we have a unicast, local link, multicast groups also assigned to the interface gigabit Ethernet 000 for IPv6, not for here. Type show running config interfaces. Command display the current command applied to the specified interface as shown. The following 2 commands are used to gather more details interface information. We can use show interfaces, display information, and packet flow count for all interfaces on a device. Show IB interfaces and show IPv6 interface, display IPv4 and 6 related information for all interface. So show running config interface gigabit 000. We have a VLAN, the IPv4 address, subnet mask, IPv6 address, negotiation is auto, a related show details. Now, we need to talk about show IB interface command or show IB route command. Show IB route command usually or show IPv6 command will reveal or provide 3 directly connected entries and 3 local host router interface entries. What we are talking about here, show IB route. As you see, I have 1, 2, 3 entries. Why? Because I'm talking about router 1. How many interfaces I have in router 1? 1, 2, 3. So show IB route of router 1 will provide me with the 3 entries. C means is directly connected. link local, directly connected. So the local host route has an administrative distance 0. We'll talk about this later. Now, wait. Now, show IPv6 route. I have 1, 2, 3 entries as well. A global unicast address, directly connected, a prefix 64. Now, this one, the administrative distance is 0. Administrative distance simply used to rate the trustworthiness of the routing information received from the neighbor routes. Less number, more trusted details. Now, it will discuss in full details the administrative distance in T216B when we talk about the routing protocol configuration, such as open shortest path first. Now, as you see in the output, a prefix 32 masked for IPv4, 128 prefix for IPv6. I'm talking about the local link address here. Local host route is for routes on the router that owns the IP address. It used to allow the router to process packet distant to that IP. Packets from all other local devices to this IP address will be processed. In other way, local link address allow me to connect with all other devices on that local network directly through the direct connected number. Now, C next to the router, the C here next to the route indicates what? It's a directly connected link. So where is the directly connected link here? 1, 2, 3 IPs should be the directly connected IPs. So directly connected network. When the router interface is configured with a global unicast address and the IP address is up, protocol is up, IPv6 prefix also and the prefix length is added to the routing table as well as a connected router. What we are talking about? We are talking about the IPv6, a global unicast address. It will be added to the route table. Local link address as well, it will be added to the routing tables. The IPv6 global unicast address applies to the interface, is also installed in the routing table as a local route. Local route will have the prefix 128. Local routes are used by the routing table to efficiently process the packets with the interface address of the router as a destination. So, local link process local receives packets through that interface. It will be accepted, and even the transmission to a locally connected devices should be through the local link. How we can list the details? We can use show IP route command to list all the details of the interfaces for version 4 and version 6. Usually, as we have said, 2 entries should be provided, C and L. C directly connected link, L local link address. Now, sometimes the show output commands, it's very lengthy. Usually the base size or the output by default will present 24 lines, then it will be paused, stops. So at the end we can see more text to be displayed in case the output is larger than 24 lines. So if we press enter, we'll display the next line. If we press the space bar, it will, or we will display the next set of lines. Now, we can use terminal length command to specify the number of lines to be displayed. So terminal lines 30. So it will display 30 lines. If we have more than that, it will display more text at the end. Terminal length 0. It will prevent the router from pausing between the screen. It will present all the outputs without any pausing. So we'll not see them all in case we are presenting more than 24 lines. Default number of lines to presented by any comments 24 lines. Per output, let me say. Now, another useful issue to improve the user experience, when we use the show output, we can filter the output and focus only or display only a specific section of the output. So how I can issue show and how I can only, list or focus on a specific section only. I do not want to use all the output, or I do not want to see all the output. For example, show interface is brief, and I want only see the input errors or the output errors. So what we can do here, we can filter the output. How the filter will be enabled? By entering the byte character after the show command and enter the required filtering parameters or expression. So in general, we have 4 filtering parameters can be configured after the byte. 4 parameters. We can use section, include, exclude, and begin. Now, section is used, shows the entry section that start with the filtering expression. Show me the entry section start with this. For example, we can write show running config. Now this is the byte. Only section line VTY. So only this section will be displayed as an output. So we are filtering, controlling the show commands. We can use include parameter. Include means include all output line that matches the filtering expression. Show IB interface brief, include up. So any output matching or including the up status will be displayed. Exclude now, the opposite of include. Excludes all output lines that match the expression. Show IB interface brief, exclude unassigned. So any matching here for unassigned, it will not be displayed. Finally, begin. Begin is used, shows all output lines from a certain point, starting with line that matching or matches the filtering expression. Show IP route, begin, gateway. So it will display the output starting from a line matching the input value gateway here. So from a gateway word to the end of the output will be presented. So we can use section, include, exclude, and begin to filter the output and display specific output section. Command history. The command history feature is useful because it's temporarily store the list of executed commands to be called. Now, to recall a previous command from the history buffer, you can use or press Ctrl P, or we can use the up arrow. The up arrow key simply, or the Ctrl B, will start showing the recently or the previously issued commands. So repeat this process or this key sequence. It will record successfully older commands. To return to the more recent commands in the history buffer, we can use Ctrl N or down arrow key. What we are saying here, I want to move back between the last 10 issued or entered commands. We can use the arrow key or Ctrl B. We want to move from an older commands to the most recent commands. We can use Ctrl N or down arrow. نتنقل ما بين الكومنتس اللي دخلناهم. في حد عنده مشكلة بالصوت غير زميلكم؟ طيب. By default, how many commands will be stored in the buffer? Last 10 commands. By default, a command history is enabled, and the system will capture the last 10 commands line in the history buffer. So we can use show history as the privilege command to display the content of the buffer. Show history simply will what? Display the last 10 entered command on the switch or the router. Can we increase the number of commands line on the history buffer? Can we change the buffering size of the history command? Yes, we can use terminal history size 20. So in this case, we'll store or buffer the last 20 entered command. We can use terminal history size 5 instead of the default 10. How we can see all the last entry commands? Show history at the privilege exit mode. طبعا, this is the end of module 1. As you see, we have only covered 1,